All right, guys, let's talk about some factoring. So far in this chapter, we have been adding, subtracting, or multiplying polynomials. And now we're going to kind of start to work that backwards. Instead of multiplying them together, factoring is like division. So if you look at what this says here, if we distributed that through, we would get this. So the 2x out here and the x plus 4 in here are factors. And then this would be the product. And the reverse of that would be taking this and figuring out what I can divide these by. So like what can you divide both 2 and 8 by? And what can you divide x squared and x by? So the 2x is going to be the part out here. It's going to be called the factor. That's where we write it. And the x plus 4 is like the remainder. So let's work on this problem. So what are the two coefficients? Remember, coefficients are the numbers out in front of your x's, or what are being multiplied by your variable. So that's 2 and 8. What is the largest factor of each? So what can both of these be divided by? Well, since 8 can be divided by 2, it actually is 2. And then look at x squared and x. What is the largest number of x's they both share? This one has 2 x's, because this is x times x. And this one just has 1x. So what do they both share? An x, or you could say 1x, or you could just say x. So the GCF is the number times the variable. So the number and the variable combination. So 2 times x, or 2x. So it's kind of, again, like doing two problems. You are dividing or finding the greatest common factor of the 2 and 8, and then of the variable, and then you are putting those together. And then to figure out what is the remainder, we divide. So this will make a little more sense once we start working on it here. So I see constants and coefficients, and I see x's. So first just look at the 3 and the 36. We can divide both of those by 3. We're going to put a 3 out in front. And then look at x, the third power, and x. They both have an x in common. So our GCF is 3x. And then to figure out what goes in here, you're dividing. So you could say, all right, 3 divided by 3 is 1. We can write that 1 or not. Let's see if we need it. And then x to the third divided by x. Basically, this x cancels out one of those, is x squared. Before I move on, I always check by distributing. 3 times 1 is 3. X times x squared is x to the third. Sweet. Okay, and then I'm going to be adding here because everything's positive. So then I do 36 divided by 3 is 12. X divided by x is 1. I don't need to write that 1. So that is the end. And again, to simplify that down, you do not need 1 out in front of that x squared. There's certainly nothing wrong with it being there, but you don't need it. So it's kind of like we worked two problems, one with the constants and one with the x's. Anytime you have a negative out in front, and this is just going to set us up better for later, always factor out -1 if leading coefficient is negative. And like I said, that'll help us later. Today you're going to be like, well, that's annoying, but it will help us. So always factor out -1 if the leading coefficient is negative. So in this case, this is in standard form, meaning this b squared comes before the d, and it is negative. So first of all, I know we're going to factor out a negative. And then looking at 2 and 4, what is the greatest common factor of those is 2. And then now d squared and d. 2 d's here, 1 there, so we can only factor out 1. So this comes out in front of our parentheses, and then basically it's like division. -2 divided by -2 is 1. Write it or don't. Okay, or maybe I'll just make it really light there. D squared divided by d. So think about this from our last chapter. It looks like that. Where are there more d's? Or, think about this d coming up and canceling 1. So I've got d. Keep the 1, don't keep it. Now think before we do. -4 divided by -2 is +2. And then d divided by d is just 1. So we don't need to write that 1. check before we move on. -2 times 1 is -2. D times D is D squared. -2 times +2 is -4, and then D is there. So that's how these work. Just take your time. There's really no work to show is kind of a difficult part about this. Most of it's done in your head. All right, standard form, yes. X1s go 4, 2, and then 1. It is negative again. However, I look at 4, 5, and 2, and they don't have a GCF other than 1. But anytime there's a negative, I am going to factor out a negative. And then look at your C's. We've got 4 here, 2 here, and 1 here. All of them have 1 in common. So we are just going to factor out a -C. You could also write -1C. So think of this as -1. -1 times what gets me -4? Or divide. What's -4 divided by -1? Maybe we do want that 1. -4 divided by -1 is 4. And then C to the 4th divided by C is C to the 3rd. 5 divided by -1 is -5. C squared divided by C is C. -2 divided by -1 is going to be +2. C divided by C is 1, or they cancel each other out. So really do take each of these numbers and divide. Then check. Negative times positive is -4. C times C to the 3rd is C to the 4th. Negative times negative is +5. C times C is C squared. -1 times positive is -2. C times, there's nothing here, is that C. So that's how it works. All right, this one's not in standard form. So we write this term first, and then that one, and then that. Always pause if I'm going too fast. Excuse me. Looking at these constants or coefficients first, I've got 4, -8, and 28. Those can all be divided by 4. K, 6 of them here, 2 here, and none here. So that's it. All I can do on this one is pull out a 4. So that's K to the 6th. -8 divided by 4 is -2. Bring the K's down. 28 divided by 4 is a +7. So that's the scoop on that one. And then these last two. Don't really need to worry about the order on these. Technically, I believe this one should come first because it's got an x squared, and x squared would go before x. So technically, now I promise to never get this technical with you on a quiz or test as far as standard form goes. But technically, you look at in alphabetical order, and then you go with squareds. So that would be technically standard form. Look at our numbers. We have 12, 18, and 18. All of those are divisible by 6. Now look at our variables. 2 x's, an x, but no x. So that means we cannot factor out an x. 1y, and 1y. So we can factor a y out of all of those. We can factor out a 6y. 12 divided by 6 is 2. X squared hangs out there. Y divided by y cancels. 18 divided by 6 is +3. X, not dividing by anything, so it hangs out there. Y divided by y cancels. 18 divided by 6 is 3. Y divided by y cancels. So that is the end of that one. Check it. Always you can check. Oh no, yeah, I'm good. I did 6 times 2 and thought 18, but nope, it's right here. So check it. Make sure it works every time. One last one. Let's see, standard form, we would look for A's, A to the 3rd, A to the 3rd, and then next you look for B, so B to the 5th, B squared. This one is in standard form, so 6, 60, and 6 can all be divided by 6. This has 3 A's, this has 3 A's, this has no A's, so I cannot factor out an A. But B to the 5th, B squared, and B, they do all have a B in common, so I can also factor that. So you write 6B. 6 divided by 6 is 1, put it or don't. A to the 3rd isn't divided by anything, so just write it down. B to the 5th divided by B is B to the 4th. Negative 60 divided by 6 is negative 10. A to the third doesn't have any a's to divide by, so it just stays. B squared divided by b is b. And then positive 6 divided by positive 6 is positive 1. Put a 1 if you want, or just hang and see if we need it. B divided by b is also 1. Do you think we can just leave nothing back here? And then if we distribute it back through, we definitely need a 1 there as a placeholder. Think about y right here. If I multiply these two terms, I get that. These two, I get that. 6b times 1 gets me that. So I have to have that there. Otherwise, we wouldn't do 6b times 1 to get back to there. So that is it for 7.4. Do your best, ask each other questions. Remember that if you guys are getting stuck and can't help each other, or whatever sub you have, because I don't know who that is yet, cannot help you, you guys can always talk to Miss Scott down the hall. Good job, guys.